Okay, problem number 68. The height of a mountain. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. Now, again, this is going to be one of those problems that has two triangles in it, so I'm going to use a different color for each. This is the height of the mountain. Now this is not to scale, so this angle won't be 13 degrees, but it'll be good enough for our purposes. Now we're told that this, 3.5 degrees. Now that is not 3.5 degrees. But again, as I said, for our purposes, it's good enough. It's just a sketch. Now after driving 13 miles, this angle here is now 9 degrees. Okay, so we're going to have to set up a couple of things here. The only thing we know is that we have two triangles here, so let's work with the blue one first. In the blue triangle, we know that theta is equal to 3.5 degrees. We know that the adjacent side, which is this one down here, the adjacent side is going to be 13 plus x. And the height, the opposite side, is just the height of the mountain. Now in the green triangle, theta is equal to 9 degrees. The adjacent side is just x. And the opposite side is the height of the mountain. So let's set the relationship up for the blue one. We know that opposite over the adjacent implies tangent of theta. So the tangent of 3.5 degrees is equal to the opposite side, which we don't know, that's what we're after, divided by the adjacent, which is 13 plus x. So let's solve for the opposite side. If we multiply by 13 plus x on both sides, we get the opposite side. Now in the green triangle, we still have opposite over adjacent equals the tangent of theta. So the tangent of 9 degrees is equal to the opposite side divided by x. So x times the tangent of 9 degrees equals the opposite side. Now the height of the mountain doesn't change, and in both of these equations the opposite side is the height of the mountain. So they must be equal to each other. So that means that 13 plus x times the tangent of 3.5 degrees is equal to x times the tangent of 9 degrees. Now if I divide each side by tangent of 3.5 and by x, I get 13 plus x, well, let's not do that, equals x times the tangent of 9 degrees divided by the tangent of 3.5 degrees. Now this is a number. It may not look like it, but that's a number, and we can put that in the calculator and get a number for that. We have to be in degrees, so we have the tangent of 9 degrees divided by the tangent of 3.5 degrees, and that gives me this new equation. 13 plus x is equal to 2.6x. Now if I move all my x's over to one side, I subtract x here and x there, and I see that 13 equals 2.6 x minus x. So 13 equals 1.6x. Divide by 1.6, and I see that that's x. So x is going to be 13 divided by 1.6. So I see x is equal to 8.125. Now I need the opposite side, so I'm going to have to come back to one of these two equations, either this one or that one, and plug in that value of x. So let's use this one here. So x times the tangent of 9 degrees equals the opposite side, the height of the mountain. X is 8.125 times the tangent of 9 degrees. And that will be the height. Using the calculator, I'm going to take that times the tangent of 9 degrees, and I get the height is approximately 1.287. But 1.287 what? Let's go back to our problem. X was going to be in miles, so the height is going to be 1.287 miles. If we want this in feet, we would just multiply that times 5,280. And we see the mountain is 6,794.692 feet in height. That was a fairly complicated problem there, but it's doable. Let's see if I can zoom out a little bit. Well, I don't see the zoom out on this. Oh, here it is. Oh, that's not working. Okay, I'll just slide the paper up for you. Okay, now let's answer the question here. The height of the mountain is 1.287 miles, or 6,789.692 0.692 feet. And we're done.